Welcome to part one of case study Ex4, where we'll continue to delve into how to apply key operators from RxJava's Observable class. In particular, in part one of this case study, we'll show how various RxJava observable operators can be used to create, multiply, and display big fraction objects asynchronously. We'll also show how various single operators can be applied in conjunction with the observable operators. Finally, we'll also show how to create and use a blocking subscriber. As usual, you can find the source code for all the code we're going to walk through at the link shown in the bottom of the slide. Once again, we're in my IntelliJ IDE, and we're about to take a look at the source code for case study Ex4. As usual, we'll start by taking a look at the Ex4 class, which provides the main entry point into this test program. As you can see, there are two test methods we're going to be looking at. In part one, we'll take a look at the test fraction multiplications blocking subscriber method, which is going to test big fraction multiplication using an asynchronous observable stream and a blocking subscriber implementation. And then in part two, we'll take a look at the other method, which is test fraction multiplications streams. As always, we register both of these test methods with the async task barrier. We then run both of those test methods by calling the run tasks method, which runs them in the background, doing the processing off the main thread of control. And the main thread of control blocks in block and get until all the asynchronous processing is done. Let's now go take a look at the Observable Ex class, which is where all the fun stuff happens. As you can see, we create ourselves a field, which is a random number generator that's used to generate various parts of big fractions. And now let's go ahead and take a look at test fraction multiplications blocking subscriber. As always, we make ourselves a string builder, in this case, not a string buffer because of the way we're doing the processing. So we're doing this as a string builder. And then we go ahead and create ourselves an array of big fractions. And you'll see how we use the initialization syntax in Java to have 4 elements in this big fraction array. And those elements are each given different big fractions with a common numerator and different denominators. We then go down here and define ourselves an instance of something called a blocking subscriber. We'll take a closer look at blocking subscriber in just a moment. But basically, this is going to be a subscriber that will process various types of signals and allow the calling thread to block. So as you can see, we're going to pass several parameters here to blocking subscribers constructor. The first parameter is going to be a consumer that will be used to append the results to the end of the string builder. The second parameter will be an error handler, which will append the error message if there's an exception that is raised into the string builder and then displays the results. The third parameter is going to be a runnable, which will be used when all the processing is done. If everything happens to complete normally, we'll just go ahead and display the results. And then the fourth and final parameter is long max value, which will be used by the blocking subscriber as a parameter to the request call on a subscription to indicate that the publisher can send the data as fast as it wants. We could give a different value here if we so chose. Now let's go ahead and look at the main chain that we're going to put together here. So we're going to start by using single from callable, and we're going to use this factor method operator to lazily create a random big fraction. We've seen this method before, but just for completeness, make big fraction takes in a random number generator, generates a very large big fraction integer as the numerator for the big fraction, and then it creates a much smaller denominator, and then it creates a big fraction by taking the numerator plus the denominator. And as you can see in this particular case, we pass in true, indicating that we want this big fraction to be reduced when it's created. The next thing we're going to do is we're going to use the FlatMap Observable operator. This is defined on single. And what we do is we take the item that's going to be emitted by the single once it's created, and we use that to go ahead and basically create an observable, which will then be returned as the result from FlatMap Observable. So you can think of this as basically a way to convert a single parameter into an observable. And here's what we're going to do. We're going to take the big fraction 1, which is what comes back from the from callable call that we made up here to the single from callable factor method. And then we're going to go ahead and use the FlatMap concurrency idiom to convert the big fraction array into an observable. And then for each element in that array, we're going to go ahead and use the FlatMap concurrency idiom to take each of the elements in the array, and then we're going to emit it using from callable. We're going to schedule this to run in the computation thread pool. And then finally, in the context of that computation thread pool, we're going to multiply each of the big fractions that was in the big fraction array by the result that was returned from callable for the single. So what we'll end up doing here is multiplying all these values together, and we'll return an observable to a big fraction, or an observable that has a stream of big fractions. We then take the observable that comes back and we convert it into a flowable. And a flowable is another class that's key to RxJava that allows back pressure to be enabled. By default, observable does not allow back pressure. In fact, observable never allows back pressure. But if we convert it to a flowable, then back pressure can be enabled. And we're indicating here that we want to just take the latest item if we have the publisher generate data too fast to consume it. That will not be the case in this example, but we're just showing one of the overload strategies you can pass in. Then we go ahead and call subscribe, and we pass in our blocking subscriber. And we're going to take a look at the blocking subscriber in just a moment. But for now, be aware that subscribe will return because it's an asynchronous call. So because we don't want the program to fall off the end just yet, we use the blocking subscriber await method, which we'll also look at in just a moment, in order to be able to block the calling thread until all the asynchronous computations that are taking place in the subscriber and the thread pool that we're doing the multiplications in are finished. So let's go ahead and take a look at blocking subscriber. And to get there, we just have to go over to the utils folder and click on blocking subscriber. So here's what the blocking subscriber looks like. Blocking subscriber is simply a subscriber implementation that handles blocking and back pressure. And you can see that blocking subscriber implements the subscriber interface. In order to make sure that the calling thread doesn't return until the computations are done running asynchronously, we're going to use a countdown latch, which is a barrier synchronizer that's defined in Java that can be used to wait for something to finish processing. So the main thread will end up calling await on this countdown latch. And then once all the processing is done in the background, we'll essentially count down by 1 and release the blocking caller. We also provide a number of fields here. We have a consumer field that will invoke on each value. We have a consumer that could be invoked if an error signal occurs. And then we finally have a runnable field that will be the completer. So when everything is done, it'll go ahead and complete the processing. You can then see down here, we have one final field, which is going to be the long that's used to keep track of the request we're going to make to the upstream publisher, indicating whether or not it should have back pressure. As you saw from the parameter we passed in, we're saying, no back pressure, please, just send the data as fast as you can. Here's the constructor. All it does is it basically just takes these parameters and goes ahead and assigns them to the various fields. And here's where it gets interesting. So here's the await call. If you recall over here, this is where await is called, and this is where await is implemented. So you can see what it does is it uses the countdown latch to wait until another thread counts down by 1, which will release it because it starts with a count of 1. And then we return an S void C, which is just a completable that's complete. Just says, I'm done. Here's the onSubscriptionHook method. This is what gets called back by the publisher when the connection is made to the stream. And as you can see here, what we do is the blocking subscriber just says, I would like to request an unbounded number of events be sent to me. Here's the onNextHook method. This, as you can see, is overridden from the subscriber interface. And all it does is it just says mConsumer accept, which will end up triggering the hook method that will add an element to the string builder so that we can print it out later when everything's done. Were an error to occur, we would do the same thing with the error consumer. We would accept the throwable, which, as you saw, would just go ahead and log that there's an error or an exception that has been raised. And then we release the latch so that the calling thread can unblock. And then finally, we have the onCompleteHook method. And you can see here, it goes ahead and runs the hook method, the run hook method on the complete consumer, and then releases the latch. So after all the processing has been completed, then control will pass here and we'll be able to return from this particular test method. So let me go ahead and run the program real quick, and you can see what the results are. Now, it turns out that the results are going to be shown up here. So test fraction multiplications blocking subscriber. It just basically prints out the results of doing the multiplications on those big fractions that were in the big fraction array. So we had 4 elements in the array. We apply the multiplications to them. And just as a point of random chance, we ended up with whole numbers without fractions. But otherwise, if we were to run this again, we would probably end up getting different results and might have fractions this time. And indeed, you can see that we did end up with a fraction here, a big fraction. And that's, of course, because we're using random number generators to generate these things to multiply stuff by. In the next part of the lesson, we're going to talk about test fraction multiplication streams, and it has also very interesting properties, but we'll have to hold off until part 2.